Thank you for joining this lesson. We are going to handle probability. We are told in this question that the probability that our school will host soccer and rugby tournament this year is 0.8. If we host, the probability of winning soccer is 0.7. If we don't, the probability of winning soccer is 0.4. If we win soccer, the probability of winning rugby is 0.8. Otherwise, we lose, the probability of winning rugby is 0.3. Draw a tree diagram to represent this information. So we shall start with a probability tree diagram to represent the above information. We are told that our school can host or not host. Host or host not rugby tournament and soccer tournament. Hosting is 0.8. So if hosting is 0.8, you know these are mutually exclusive events. We can either host or host not. The probabilities of mutually exclusive events have to add up to 1. So this automatically is 0.2. It is not in the statement, but it should be our conclusion. That now that the probability of hosting is 0.8, the not hosting should be 0.2. Then now we are told if we host, the probability of winning soccer is 0.7. So if we have hosted the games, we can win soccer, or win not soccer. And winning soccer after hosting is 0.7, while we can still lose after hosting, which means losing is 0.3. That is losing when we have hosted. Then we are told if we don't host, the probability of winning soccer is 0.4. So if we fail to host, we can still win soccer or still lose. So winning soccer, losing soccer. Winning soccer is now 0.4, which means the probability that we will lose soccer is 0.6. Then now finally we are told if we win soccer, the probability of winning rugby is 0.8. So we win soccer, we now win rugby, or still fail in rugby. So winning soccer then winning rugby is a 0.8. So it means 0.8. So losing is 0.2. If we win, the other probability of winning soccer is here. We can still win rugby and lose rugby at 0.8 and 0.2 respectively. But now if we had not won, if we lose in football, or rather soccer, winning rugby becomes 0.3. So if we had lost in soccer, now we can still have rugby or rugby not, and winning rugby is now 0.3, which means losing it is 0.7. If we had lost, winning in rugby is 0.3. So losing in rugby is 0.7. 0.7. So this is the probability tree diagram. After this, we use now the tree diagram to find Roman 1, the probability that we lose both games. So losing both games can be through we host, we lose, and we lose. Or we host, we lose, and we lose again. So we can either fail to host and fail to win all of them, or still host and win all of them, which means it is the probability of hosting then losing the two, or failing to host and losing all of them. So hosting is 0.8, losing 0.3, and the other losing 0.7, or which means addition here, we fail to host 0.2 and we lose 0.6 and we lose the other game 0.7. So this is now the probability of losing in all the events, which is going to be 0.8 by 0.3 by 0.7, or means addition 0.2 by 0.6 by 0.7 and this is going to be 0.252. That will be the probability of losing in both games. The probability that we will win only one game. So winning only one game, now this one is a bit diverse. We can win soccer and lose rugby, or lose soccer but win rugby, or to this other side, we win soccer and lose rugby, then finally we lose this one, the soccer, but we lose in soccer but we win in rugby. As long as it is only one game, then the positions or the the probability of winning only in one game, we have the options here now, very outright. We can start with 0.8 times 0.7, then winning in that game, we want the other one to be a loss because we want winning only in one game. The other one can be we host but we lose football, then win in rugby, which is 0.3. Or on the other side, we fail to host, 0.2, then we win soccer alone and end up losing rugby, 0.2. Or finally, we fail to host, we lose in soccer but win rugby, so that is winning rugby alone. So let me compose now this answer. So we shall have 0.8 by 0.7 by 0.2, or which means addition 0.8 by 0.3 by 0.3, or which means addition 0.2 by 0.4 by 0.2, or the last addition 0.2 by 0.6 by 0.3. So this is going to be 0.236. That is the probability that we win only in one game. We have another question here. The probability that we will host and lose both games. So probability of hosting and lose in all games is hosting, then losing in soccer, and we also lose in rugby. So hosting 0.8, losing in both games 0.3, losing soccer, and after losing soccer 0.7, losing in rugby. So this is going to be 0.8 by 0.3 by 0.7, and this is going to be 0.168. 0.168. Finally, the probability that we win at least one game. Probability we win at least one game. So we're going to get 1 minus the probability of losing all games. So 1 minus the probability we lose all the games. So the probability that we win at least one game will be 1 minus probability that we lose everything, which is going to be hosting and losing everything, soccer and rugby, and failing to host and losing everything. So this is going to be 1 minus we host 0.8 but lose soccer 0.3 and lose rugby 0.7, or this should be curl brackets, we fail to host and we end up losing in soccer 0.6 and 0.7 respectively. So we shall have 1 minus, when we have 0.8 by 0.3 by 0.7, then we had 0.2 by 0.6 by 0.7. This is going to give us 0 0.252. And now when we take 1 minus this one, we shall have 0.748.